Hello, and welcome back to the non-serious circuit. So we are going to see how this series circuit works. Oh, you've noticed, yes, I did change a label. What I have drawn is what the circuit looks like visually. 120 volts AC plugs into house current. You can see current can flow through the switches, up through the filament of each bulb, and back out to house mains. That's how it looks like it's wired. But there are a couple of hidden components. Let's put those into the circuit. I've got a diode across the switch terminals in each switch, and they're facing opposite directions. And then up here inside the light bulb, everything is inside this sleeve or ferrule or barrel or whatever you want to call that. With the current configuration, switch is open, there will be no current flow. And I can draw that out for you. And I'm going to go through the diodes using negative electron flow. I just think this will be easier to visualize. So we can show you with switches open why neither bulb will illuminate. Let me draw that. We can't go through the switch, nor can we go through this diode because of the way it's positioned. So there's no current flow in the downward swing. So in the upward or positive cycle, if we follow electron flow, we can go through this diode, and this diode will shunt the filament. And what that will do is, while there will be a tiny amount of current going through this filament, it will not be enough to light that filament. So the current will continue through the diode, then we continue through here. This diode will not allow current to flow, and so this is forced to go up and through the filament. So we come down here, we get to the open switch, and this diode will not allow current to pass, neither will that switch in the open position. So again, no current flow. Let's close the green switch. Negative cycle here. Comes through the wire. This switch will allow it to pass regardless of what that diode, I'm going to go up over the switch, regardless of what position that diode is in. This switch will not allow current to pass, but the diode will. So we'll go through the diode, and then following the wire around, this diode is going to shunt current, not allowing that filament to light. So following the wire around, this diode wants to block it, forcing it up through the filament, and if we follow it out, it can make it back. And this illuminates this bulb, which now we know is the green bulb. So that's how the green switch can turn on the green bulb, but not the blue bulb. We'll make this one blue. Pretty cool, right? If we follow the positive cycle through, this diode will shunt current away from that filament, as I described before. It'll continue on. This diode will not let it pass, so current could go through that filament if it makes it all the way around. So we come around here and we get to the switch. It can't go through the switch, and this diode is blocking current. So even though there's a path here, that diode will block current flow in this direction. We have no bulb illumination. Let's change the switches. Again, starting with the negative cycle, or the downward cycle. If current is flowing in this direction, we get to this diode, and it cannot flow through the diode, nor can it flow through the switch. So no current flow again on the negative cycle. Now when I do the upward cycle, positive cycle, this diode shunts current through it away from the filament. This diode is going to force it up and through the filament. Current's going to flow through the switch rather than the diode. This diode is going to allow current to pass, and it can make it on out, illuminating the blue. We have a complete circuit in this path. As you can see, that's how this switch can be assigned to this bulb and this switch assigned to this bulb. But what about when I swap bulbs? So what I'm going to do is swap the bulbs, which takes the diodes with them. That is the blue bulb, green bulb. So what does that do for us? Well, with the switches open, as before, current would not flow. We will close the green switch and start by tracing the negative swing of the AC. That will come through this switch, will short this diode. Doesn't matter what orientation it is. Passes current on. This diode will allow current flow even though that switch is open. So we follow that around. This diode will not allow current flow, forcing current through the filament. Now let's see if we could complete the circuit. We come over here. This diode shunts the filament and completes a circuit. And the green light illuminates even though we swapped it away from its original socket. In essence, that's how the magic trick works. I can show you, I'm going to trace the other cycle while we see the negative swing. I'll trace the positive swing and show why both don't illuminate at the same time. So we have current. That diode forces up through the bulb, continues this way. This diode shunts away from the bulb, and we continue coming down here. Once we get to the switch, this diode will not allow current to flow, and the blue switch is open, which will also not allow current flow. So that's showing both cycles of the AC and why it doesn't flow. Just for fun, I'm going to close that blue switch. AC, or the positive flow of current can come across that switch. This diode is going to bypass the switch, or it can go through the switch. You'll probably measure current in both, so I'm going to draw it this way, and it completes the cycle. And you could probably measure current in both there as well. And so with both switches on, both lamps will illuminate. It's kind of a cool circuit, and it's surprisingly elegant for how tricky it is using just 4 of the same component, using 1N4003 diodes. Let's see how they're put into each of the components, shall we? I'm going to do green again, and I've got 1 red left. For the green bulb, I'm going to have the diode installed with the stripe towards the filament, and then for red, I'm going to do diode towards the tip, the other end towards the sleeve. While building this, one of the mistakes that you might make is losing track of which bulb has which orientation of the diode. The other hazard is, well, either filaments burning out or breakage. Okay, to prepare the bulb, I use a butane torch. These get really hot, and I'm always worried about them shattering, so safety glasses. The glue inside will catch fire, but you will see quite often fire will come out that hole, like that. There's probably a nicer way to do this, but it's worked for me. Oh, the other thing you have to be careful, other than burning your fingers, is don't crush that socket It's very thin metal and it will crush. So yeah, back when I originally made this, I went through several bulbs, learning, how much force can you put on this. This part is the hardest part. It's the scariest part, probably also the most dangerous part. But once the glue does break free, it comes off. There we go. Nice and easy. We'll set the red bulb aside, and now we'll tackle the green. The trouble with this is you don't know how well you've done until you reassemble the bulbs and try to fire it up. That was exciting. There was a time where I got pretty good at this process because I used to show this box off all the time, and without fail they would try to unscrew the cap thinking, oh, he must have just put a sleeve over it or a fake bottom or something, and people would either twist it or just pull straight on it. I went home with several broken bulbs. Yeah, nobody actually wanted to try to fix the bulb for you. No. I'm gonna let them cool for a second. Inside here will be burnt, flaky glue residue. And you need as much room as possible inside there. And on here, I like to try to scratch away as much of this burnt glue as possible. What you have left here, you'll have a very fine wire from one side of the filament, and up here you'll have the hook of the other end of the filament, which lines up with that solder blob. Where this hook hooks over the glass is where I'm going to solder on the diode, and to do so I scratch the edge of that filament lead just enough so I know I could get, you could kind of see it shiny there. That's enough so I can solder my diode to. For one of the diodes, I clipped the anode off and I set that on my drawing on the red. And then for the other bulb, I clipped, or the other diode, I clipped the cathode down. And this one, I bent a little hook. There we go. Each of these bulbs have this glass, kind of like a pipette, I guess. I think that's where they draw the air out of the bulb and then seal it up. So you can't break that. That has to stay intact. And I really wish my camera would stay in focus. So the point of cutting this with the hook the way it is so I can test fit it down beside the pipette and have enough curved back to touch that copper while leaving enough clearance between the body of the diode and the side of the socket that has to get glued back on here. And the other thing I look for is the length from this wire. That tells me where the end of the socket's going to be when I put the socket back on. So it's just kind of a visual gauge, and we're going to bend this wire in a moment so you can see what that looks like. Trying to wet some solder onto that filament lead. Okay, gonna get some solder on that. Well, that is soldered on. Gonna bend the other end of this wire. When it's centered with the bulb, you could bend it back up, because what's going to happen is that's going to come through and fit down. So a quick test fit. The next thing to do is I'm taking that other filament wire and I'm going to solder it to the other end of the diode. So added some solder so I can melt it down onto that piece of wire. Going to line up that solder blob and heat it up as I push it in. Woo, that's hot. So the next thing to do, I'm going to cut a little bit of the end off. Build that up with a bit of solder. Make it look like it should. Okay, that looks a bit better. Now here's kind of a secret tool I've used. Shaping that tip after a mess like that. And sometimes if you get too much solder on that sleeve, you can knock that down with this. So here we go, starting all over. So again, scratch away this the old glue. Be careful around the wire, and I've scratched away some of the copper there. I'm going to make a hook. Looking back to my drawing, I know that the cathode, or the stripe, is going to go towards the bottom of the bulb. I've got the stripe on the long end of the lead. Scrape this copper just enough to get a shine. There we go. Put that on there. We will get that solder started and smooshed in. So we cut this down pretty short. So it's flattened, but now let's clean that up. There. And now it looks like your standard bulb. That can't be blue anymore. So we've seen how the bulbs get put together, and now I want to show you how the switches get put together. So I was asked about inspiration and stories about this circuit, and I went to school for engineering electronics from 92 to 94, and I loved circuit level or component level troubleshooting. And man, especially if you have a schematic and the proper test equipment in your hands, you can unlock just about anything. Anyway, as we were learning about semiconductors and solid state components such as diodes, transistors, SCRs, etc., I would look through Popular Electronics magazines and came across this exact circuit. And I thought it was freaking amazing. I had never seen a diode used to indicate polarity on an analog or something like a bulb, which can respond to AC. That's non-polar. I guess a better way to put it, I was fascinated that you could add a diode to a component that is non-polarized, essentially making it polarize, which now is quite obvious, but back when I was going to school, it was magical. So let's open this switch up. This gold piece is a rocker, and it is touching, you can see it's touching the silver conductor here, which continues and goes out the bottom and it becomes this lead. So let's get that rocker out. And if we look in here, you could see the diode. In this case, the stripe on the diode, that would be the cathode, is on this side of the switch body. That extra bit of wire is in there to help me position and move things around, I just pushed up on the bottom conductors here, and that pushed the plates up together. So here's all the guts exactly as is. This would be the lead that goes through the bottom of the case, and that would come forward, has that little bent tab right there that the rocker fits in. And then you've got the other lead, goes down through the case, and this comes forward a bit and then turns, goes out towards the center. Now for the diode, in this particular switch, coming off this edge, I've got the package with the cathode marking on this side, and then you've got this wire here that allows me to adjust these two leads as I'm putting them in. This looks like this. The other switch is exactly the same as this, except that this package is reversed, so the diode is in the opposite direction. Getting it back in is a little bit tricky, but among the easier of the tasks. Wiggle these down till those legs come through. That little swinging contact. Make sure that that flag goes towards the other contact and that it moves somewhat freely. You put the spring over that with the cup upward. Make sure the spring is sitting straight up and down. It can rock sideways as you're assembling it, and that would be bad. And what I'm looking for is clearance over the diode body on the swing away from the contact. And now to put the switch together, I make sure that slot is going away. Whee! So again, let's see, slot towards negative. And now before I screw it all down, I check to make sure it feels proper. So yeah, before you take apart your switch, make notes on any kind of markings, how it's oriented. Make sure to feel the switch action, feel how hard it is to move and how snappy it is when it clicks. Oops, forgot I had left that on. Here we go. Maybe I should do it that way. If you attempt this project, I would love to see your results. Remember, you're dealing with high voltages and high temperatures, so please take care. Take all the necessary precautions. The high voltage is obvious. That's the house mains current, which is why I have this in a clear. Oh, this is a VHS tape box. That should give you a clue as to what era I built it. Keep fingers away from exposed high voltage areas. Your high temperatures, such as your torch and soldering iron, can also be dangerous. Not to mention the glass bulbs, if they burst, could send glass fragments. So wear eye protection. Thanks for watching.